Okay, here is your problem 21, and luckily it is a go problem, which means I think you can hit things or go to tutorial and things like that to do. But so it's kind of I mean, this is kind of a teeter-totter problem on steroids, but if we break it down, if we just break it down into its components, then we should be fine. All right, and so here's what we've got. We basically have a hinge here, and then a wall, and then we've got the beam going across here, and it's being held by this brace. All right, it's being held by this brace, and this angle is 42 degrees in my problem. All right, and this brace is down here at this wall. All right, so now it told us that there's a vertical force here at the hinge, there's a horizontal force here at the hinge, the weight of the beam is right in the middle. The weight of the beam is right in the middle, and then we've got the brace having a force going off this way. Okay, so there's the force on the brace now, caused by the brace. Now the brace has a bx and a by component. The beauty of vectors, I can move them to wherever I want. Now, they want us to find this, this, and this. Okay? All right, so here's what we're going to do. We know that this is in equilibrium, so the sum of the forces, the sum of the torques is equal to 0. And let's pick a convenient spot to do our torques. And the convenient spot, point where the hinge is, at the hinge. All right, that's where we'll do it. Because then I can, now you might be going, well, wait a minute. They told us it's a uniform beam. You're going, wait, I need the length of the beam. It'll cancel. Whenever you're not given something, trust me, all these problems have been well vetted. That's why I don't make up the problems, because I would forget something like that, or forget that you can that it will cancel. So let's go ahead and look at the sum of the torques. All right, so sum of the torques about this point here. So H and V have no torque, or applying no torque at that point. If I picked this one, I'd get rid of W, but then that's the only known that I have. I don't want to do that. All right, and so, well, we also know that this is 42 degrees. Okay, so sum of the torques now. At H, let's just walk out here. Well, we're assuming that the center of mass of this thing is at the middle of the beam. So I'm going to say, well, the weight, now this looks like it's causing, right-hand rule number one says, look at my fingers, they're curling as I put them in the direction of the weight and then curl it towards the pivot point. That's going clockwise, so that's a negative W times 1/2 times the length of the beam, okay, plus By is right here. The Y component of the brace is right there, and that is B plus B times the sine of 42 times all of L. Well, there you go. You know this. It looks like, now let's just set it up. So we've got 1/2 W times L is now equal to B sine of 42 times L. Wow, cancel L's, cancel lengths, and we've got 1/2 the weight is equal to B times the sine of 42. And so I can just say, well, B is equal to W over 2 times the sine of 42. Now I kind of did a little bit of algebra there. This is 1/2 of something is equal to that something divided by 2. And so that's what we've got. And then you can find out what B is. And then the beautiful part of this, let's look at what the sum of the forces we need to find h and we need to find v. So the sum of the forces in the x direction are equal to 0, and that would be minus h plus bx. Well, you know what b is, and bx is going to be the cosine of 42. B times the cosine of 42. So you can find h pretty easy. And then you can find the sum of the forces in the y direction the same way. You've got 0 is equal to positive v minus w plus by. Where bx is equal to b times the cosine of 42, and by is equal to b times the sine of 42. Okay? All right. Sounds good.